Theoretical physicists strive to decode everything in the universe with just mathematical formulae alone. They are now tackling the last big question left for the human race. How did the universe begin? It seems a daunting question, but in fact, physicists already know where the answer lies.
These would be places where all our ideas of space and time broke down. Science would therefore not be able to determine how the universe began.
These places Hawking speaks of are the black holes that swallow up everything with their enormous gravity. Not even light can escape their dark depths. But if their center could be expressed as a mathematical formula, everything in the universe could finally be explained. This would be the ultimate formula. In their quest for this formula, however, physicists have faced unimaginable obstacles. Can humankind explain the creation of this universe? Armed with formulae alone, physicists have aimed for such lofty heights. This is the story of the brilliant physicists and their century-long journey. Among the mountains of Colorado, USA, lies a place of inspiration for physicists from around the world who gather here each year. The Aspen Center for Physics has seen numerous major discoveries.
Welcome, John Schwartz.
In 2012, to celebrate the center's 50th anniversary, a distinguished physicist was invited to speak.
Good evening. So it's my pleasure.
John Schwartz is one of the physicists who has come closer than anyone to the discovery of the ultimate theory.
Never emphasized the role of Aspen in my...
Schwartz came up with a new theory called superstring theory. He described a previously unimagined world of elementary particles flying about like quivering strings. But we'll come to that later. Let's first take a look at the place that inspired Schwartz to set out on his journey to discover the ultimate formula. This observatory is found on the top of a mountain just outside Los Angeles. It's a historically important site, once visited by a certain physicist.
Oh, here's a picture of Einstein up here.
It was here that a discovery was made that would revolutionize the world of theoretical physics.
The universe is expanding, which was a major discovery.
Ever since the Big Bang 13.7 billion years ago, our universe has been expanding, starting from a single point. Physicists have been able to use formulae to explain everything in the world from 10 to the power of minus 43 seconds after the Big Bang. In other words, only the actual moment the universe came into being remains a mystery. The ultimate formula would unlock the secrets of the beginning of the universe and explain everything in existence. And it was one brilliant physicist who began this epic journey.
Albert Einstein.
Albert Einstein is a legendary figure in 20th century physics. He marked his place in history with his general theory of relativity. In an age without giant computers, he succeeded in accurately showing the movements of the distant universe. There was hope he would finally solve the mystery of the origin of the universe. This is the formula for the general theory of relativity. It may look complicated, but its meaning is surprisingly simple. The left-hand side of the formula represents the curvature of space. The right-hand side contains symbols representing mass and energy. In other words, the formula explains that where there is mass or energy, there is distortion of space. But it's still a little hard to picture.
So let's make a simple model of Einstein's theory of gravity using some everyday objects. It would be like the star.
Explaining the concept is Joseph Polchinski, one of the physicists seeking to discover the ultimate formula.
We need a sheet, which is going to be space. And so here we have a nice model of this effect. So this is supposed to be space here, and there's no matter, and as you see, it's nice and flat. But now suppose we have a large mass around, like a star. What that will do is it will bend space by a lot, as you see. And now, if we have a planet moving, of course, it's not going to move in a straight line, it's going to move in a circle, and it's going to orbit around the star.
When you think of gravity, you probably imagine a star that's drawn to another star and moving in a circle like so. According to Einstein's theory, however, the mass of a star causes space-time to distort, and as a result, the other stars follow the curvature created by this mass. This space-time curvature becomes more extreme and more powerful the smaller and heavier the stars are. Using this theory, Einstein made a bold prediction. Where there is intense gravity, even light will bend. If this theory were indeed correct, it would mean that even a star hidden behind a larger star would be visible as gravity bends its light. And his prediction was proved right. This is a photo of a total solar eclipse. The stars seen around the sun appear slightly away from where they actually are. This is because the sun's massive gravity has caused the light of the distant stars to bend. How did the universe come into being? It was hoped the general theory of relativity would solve the greatest mystery still left for humankind. But there was an unexpected pitfall. It was the eminent physicist Stephen Hawking who pointed this out. Despite battling a debilitating condition that paralyzes the nerves of the body, Hawking has engaged his brilliant mind to tackle the mystery of the universe's beginnings. The universe originated from a single point and continues to expand. If we turn back time, we can recognize another similar phenomenon. It's the phenomenon surrounding black holes. What Hawking proved was that the center of black holes and the Big Bang were mathematically the same. After a massive star explodes, a black hole is created, swallowing up everything around it. If the center of a black hole can be calculated, the moment the universe came into being could also be explained. But there was one problem. Let's go back to the general theory of relativity. The smaller and heavier stars are, the greater the space-time curvature. Black holes with their extreme gravity sink down infinitely toward a single point. The problem was this infinite depth. This is the formula for black holes. If we were to extract the general meaning, it would be something like this. R is the distance from the center of a black hole. The closer you get to the center, the greater the distortion, represented here by the letter D. However, at the center of a black hole, the distance r is 0, and therefore the denominator becomes 0. This would result in infinity. Infinity means that this equation is impossible to calculate. In other words, the equation for the general theory of relativity cannot be applied to the center of black holes. If we cannot explain the center of black holes, the mystery of the universe's origin will remain unsolved also. It turned out that the general theory of relativity wasn't the ultimate formula after all.
These would be places where all our ideas of space and time broke down. Science would therefore not be able to determine how the universe began.
The great blueprint of the universe was proving elusive. Physicists still had to resolve the issue of infinity. And then a bold idea occurred to them. Why not combine the general theory of relativity with another formula? That of elementary particles. The formula for elementary particles describes with amazing accuracy the micromatter that shapes this world. But why combine this formula with that of the general theory of relativity? The center of a black hole is an infinitely compressed and minuscule singular point. By incorporating the formula for elementary microparticles, it was thought that the problem of infinity would be resolved, and the mystery of the origin of the universe would finally be unraveled. It was a Russian physicist who first tried to discover the ultimate formula by combining the general theory of relativity and the formula for elementary particles. There is a forest outside St. Petersburg where people rarely visit. Here, there is a tombstone marked with 2 bullets. This is the grave of Matvey Bronstein, a brilliant physicist persecuted and killed in the Soviet era.
Hello. Hi. Good morning. Yeah.
His 82-year-old daughter still lives in Russia.
Very nice to meet you.
Nice to meet you.
Bronstein died when he was 31. His family was not told of his death for more than half a century.
I was 6 years old. He was arrested on my 6th birthday. All my memories are in fragments, like pictures. I don't remember actual conversations or situations.
What fate befell Bronstein in his pursuit of the ultimate formula? He was born to a poor family and was a self-taught physicist. By the age of 19, he had mastered the general theory of relativity and the elementary particle formula at a time when most physicists struggled to grasp such concepts. Bronstein sought to demystify black holes, but before he could calculate its center, there was something he had to prove. He had to see if the two formulae could be combined and work together at the micro level in the space around him. He took a section of space at a scale even smaller than elementary particles and calculated the gravity acting upon it. Here, the two formulae that Bronstein used have been replaced by modern formulae. They may seem rather difficult, but simply put, this is what they mean. The first part of the elementary particle formula states that it involves calculations concerning the micro world. Inside the blue box, the formula describes micromatter and the forces acting upon it. Bronstein inserted the general theory of relativity into this formula. And then, a surprising result was produced. A zero appeared as the denominator. This could only mean one thing: an impossible calculation, otherwise known as infinity. Surely the correct formulae were combined, but why would they produce such a result? Bronstein proceeded to make further calculations with even greater precision. But in the end, all he got was an infinite number of infinities. What these results suggested was that if we look at what's around us at the micro level, everything is unstable and filled with black hole-like phenomena, giving rise to infinity. With the problem of infinity still unsolved, Bronstein had unwittingly unearthed a further riddle: that we were surrounded by a vast quantity of infinities. Meanwhile, in the Soviet Union, horrific events were unfolding under Stalin's rule. It is thought that as many as 1 million intellectuals and other citizens were being ruthlessly persecuted. Scientists with their free thinking were obvious targets. Bronstein, however, remained oblivious to what was going on around him and continued to wrestle with the problem of infinity. Why did the results always produce infinity? If the calculations were correct, the space around us may one day collapse. In August 1937, everything came to an abrupt end. Bronstein was captured by the secret police. he was immediately shot to death and buried in the forest. After Bromstein's death, efforts to solve the problem of infinity continued for nearly half a century. The most gifted physicists tried to unlock the mystery of the universe's origin by combining the two great theories. But not one of them succeeded. A massive pitfall loomed before these brilliant minds. To attempt to solve the problem of infinity is to throw away your life. This was the view of most physicists as they abandoned their quest of discovering the ultimate formula. But in 1974, there was a major turning point. A paper was published that claimed to have found a formula that solved the problem of infinity. Its authors were two unknown researchers who had met at Princeton. The young physicists were John Schwartz and Joel Scherk, who was originally from France. Their research was in a neglected field seen as old-fashioned at the time: string theory. Let's take, for example, elementary particles, the smallest units of matter. In string theory, these particles are not thought of as points, but as quivering strings of various shapes. This seemingly odd idea is based on an old physics formula that had been disregarded. Not to be discouraged, they developed string theory and proposed a new superstring theory. The formula they came up with succeeded in solving the problem of infinity, where the great general theory of relativity and the elementary particle formula had failed. How did the two young physicists solve this great riddle? This is a formula that combines the general theory of relativity and the elementary particle formula. The part inside the square expresses the fact that all particles are points. This shows the force between particles that fly about at the micro level. When expressed as a simple formula, the denominator is r squared, where r is the distance between the particles. If the particles are points, the moment they collide with each other, the distance r becomes 0. Then we have 0 as the denominator. In other words, we get infinity the moment when particles collide with each other. But if you remember, in superstring theory, particles are not points, but strings shaped like rubber bands. If particles are shaped like bands, they take up a certain amount of space. So even if they collide with each other, they will never end up smaller than the width of the band. Even at the moment of collision, the distance r does not become 0, and we do not end up with infinity. The superstring theory finally solved the riddle of infinity that had been troubling physicists for nearly half a century. It also opened the way for unlocking the mystery of the origin of the universe.
It wasn't a problem that a lot of people were working on, but some of us were aware of it. and that was missing in all previous approaches. And so that's why both of us became dedicated to the idea that that was a worthy thing to dedicate our efforts to.
However, mainstream physicists paid no attention to their superstring theory. They were suspicious of superstring theory. For one, the formula looked too different from the general theory of relativity and the elementary particle formula. That was not all. For superstring theory to hold true, it needed not just the 4 dimensions of the world we see around us, height, width, depth, and time, but it required no less than 10 dimensions. That's right, 10. Many physicists were skeptical of this talk of extra dimensions. Superstring theory cannot be called physics. Those who carry out such research must be excluded. These were the opinions voiced at the time. Schwartz frequently received sarcastic remarks from one particular Nobel Prize-winning physicist.
I think he was skeptical about this program, string theory program. He felt that it was too far removed from experiment, and this bothered him. He would tease me about it. He would see me in the hallway, and he would shout in the distance, "Hey, Schwartz, how many dimensions are you working in today?"
With their superstring theory still widely dismissed, Shirk fell ill with severe diabetes and returned to France. Why 10 dimensions? And where were these other invisible dimensions? These are papers all written by Dr. Shirk. Shirk is said to have thrown himself into research on extra dimensions like a man possessed. He wandered the streets in search of these extra dimensions. He became an ardent Buddhist and devoted himself to meditation.
And sometimes you would feel rather isolated because you knew the only other people, just a few of you working on one thing. Sometimes that would be a bit frustrating, you know, because people felt they weren't convinced of what they were doing, so he used to get frustrated.
Shirk's life came to an untimely end at the age of 34. In his room, there was evidence that he had injected himself with a huge dose of diabetes medication.
Joel Shirk was a remarkable person because he had this extraordinary creativity. In the times he was working with me, he definitely contributed his share of the ideas. Had he been healthy and survived, there's no question, but through the 1980s and beyond, he would have been a major player in all of the developments. That's clear.
Shirk passed away before he could fulfill his dream of discovering the ultimate formula. Schwartz, on his own, pursued the goal his friend could not achieve. While other physicists won prestige with illustrious achievements, he continued to focus on superstring theory. Then became a turning point. A new member joined the research from across the sea in England. It was a brilliant physicist named Michael Green. Schwartz and Green decided to approach the question of extra dimensions in the following way. There has never been any mathematical proof that there should only be 4 dimensions in this world. If the formula says 10 dimensions, then perhaps it is our widely held beliefs that are wrong. The two physicists set out to test once more if the formula of superstring theory was worthy of being the ultimate formula. They needed to prove whether or not the general theory of relativity and the elementary particle formula could be found within the formula of superstring theory. Through complicated calculations, the two vital formulae emerged. It was when they were doing the last calculations to ensure there were no contradictions in the formula that they encountered something strange. The number 496 kept appearing over and over again. "496 is known to be a perfect number and was revered by the ancient Greeks as being connected with the creation of the world. Its simultaneous appearance was evidence of the beautiful harmony between the vast universe and the micro-world that exists within the formula.
And it was 496, so that that was a great moment. My memory is that, whilst we were discussing this number, 496, there was thunder and lightning around. I then said something like, "This must be God, we're getting too close to the answer, and God is angry with us."
At the same time as this appearance of the number 496, they succeeded in deriving the general theory of relativity and the elementary particle formula without any contradictions.
And this at the time seemed like a miracle. It's a kind of a funny situation where we happened to stumble on a theory which in a sense was much more clever than we were, because it contained all these deep truths that we didn't really understand.
Word of their findings from their calculations spread across the world in no time.
I didn't consider it plausible that all that was happening by coincidence. I viewed it as a kind of signal from heaven.
Physicists around the world jumped on the bandwagon and started research in superstring theory. All of a sudden, superstring theory found itself at the forefront of physics. Physicists had finally come around to the idea of extra dimensions. But where do these extra dimensions actually exist in this world? You may still be struggling to get your head around the idea. Joseph Polchinski will now explain the concept of extra dimensions.
Our acrobat, Erica, sees the tightrope as a one-dimensional world. She can only move forward and backward. To this ladybug, which is much smaller, the rope is two-dimensional. The ladybug can move along the rope or around it.
As Polchinski says, The rope is two-dimensional to the ladybug. In other words, by shifting our attention to smaller scales, we start to see previously hidden dimensions. So where can we find this 10-dimensional world described in the superstring theory? It exists in the tiniest micro-world. A world so microscopic, it's a trillionth of an atom. These oddly shaped round objects are what physicists think of as part of these extra dimensions. As these extra dimensions lie hidden at the ultra-micro level, they are usually invisible to the human eye. The new superstring theory incorporated the two great formulae, the general theory of relativity and the formula for elementary particles. Was this the ultimate formula that would finally decipher everything in the universe? Yet, a sense of uncertainty remained on the road ahead. This is where our genius, Stephen Hawking, enters the story once again. He was the one who presented physicists with the problem of infinity when it came to black holes. Did the superstring theory have what it took to be the ultimate formula? Hawking answered this question by pointing out yet another problem lurking in the depths of black holes. And so begins the next chapter in our story. This new problem concerned the mysterious heat generated at the center of black holes. If you recall, at the center of black holes are singular points compressed to infinite density. It should be impossible for any movement to be there. If even elementary particles are unable to move, how can any heat be generated? This came to be known as Hawking's information paradox and was to prove a stumbling block for physicists.
He was very skeptical about string theory, but his arguments looked pretty good. And so it was really hard to figure out what he had done that was wrong. And yet many of us felt there had to be something wrong, even if it wasn't obvious.
And this is where a new hero arrives on the scene. The young physicist was Joseph Polchinski, whom we have already seen explaining various concepts. Polchinski succeeded in further developing superstring theory. Superstring theory describes a micro-world where particles fly about like small, quivering strings. An idea came to Polchinski one day when he dropped by at a laundromat during a break from a conference. He thought clothes are made up of many fine threads woven together. In a similar way, perhaps particles at the micro level are not single strings, but bundles of strings.
What's really interesting is what happens when you get many of these together. Just a few and then more and more. And, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120,
Working on a formula, he proposed that there weren't individual strings, but in fact many strings moving together, forming a kind of membrane. Polchinski's findings got physicists around the world working on calculations to identify the heat inside black holes. And finally, with the addition of this new formula describing the membrane phenomenon, superstring theory was used to successfully calculate the heat inside black holes. At the heart of black holes, particles were thought to be infinitely compressed and unable to move. However, extra dimensions might exist at the heart of black holes too. In these extra dimensions, strings woven together into membranes move around, generating heat.
I think that Hawking's information paradox is one of the great thought experiments in the history of science. If he had not argued so clearly that this paradox existed, people might have not given it the attention it deserved.
In 2004, Hawking made a bold decision to hold a conference to admit he was wrong.
I want to report that I think I have solved a major problem in theoretical physics that has been around since I discovered that black holes radiate thermally 30 years ago. My paper on information loss in black holes prompted 25 years of argument, during which we learned a lot. I am happy that we have now found that information is not lost. History would be blank. We have discovered a great deal, and may be close to discovering the ultimate theory.
The Hawking paradox was overcome, and a new superstring theory had been developed. With this formula, could humankind finally succeed in solving the mystery of the origin of the universe? On the long road to the ultimate formula, physicists had encountered infinity, extra dimensions, and black holes. At last, they are getting a glimpse of the beginning of the universe. Researchers around the world are now testing the predictions made in superstring theory. CERN is the world's largest particle physics laboratory, and where the Higgs boson was discovered. One of the next goals is to discover extra dimensions. The aim is to use a massive accelerator to reveal extra dimensions hidden at the micro level. Attention is also turned to the black holes that physicists have studied for so long in their quest for the ultimate formula. Scientists around the world are now trying to directly observe the mouth of a black hole. Superstring theory continues to be used in the latest research in physics. Its creator, John Schwartz, used a neglected concept to develop a new theory and inch closer to the ultimate formula. But he is beginning to feel that he may not live to see the day the secrets of the origin of the universe are finally unlocked.
Well, I think we're going to go very far in those directions, both for the universe and for the tiniest objects. On the one hand, it's sad that we don't know the final answer. On the other hand, it would be sad if we did know the final answer, because what would we do then? So the quest is much of the fun.
How did our universe come into being? The latest formulae describe a universe of 11 dimensions. What's more, there is a new problem that presents the possibility of there being a mind-boggling 10 to the power of 500 universes out there. The ultimate formula will unravel the deep mysteries of the universe. Until the very last mystery is solved, humankind will continue its unyielding quest.